Be here, everybody. This is a great group. I highly encourage everybody to actively participate in this group. It's always a wonderful team to work with and a very open team too. My name is Steve Manini. I am the CEO of a company called Helios Software, and we're based in the Boston area. And we predominantly do engineering services in and around fire and healthcare products more generally. We have a wonderful team of consultants, and I'm an active developer as well and hands-on person building a lot of these products for our clients. We focus on new product development. We also often get ourselves involved in what's called turnaround work, project turnaround work for efforts that need some additional expertise. And we also heavily work on fire. We've built several products on fire, do a lot of consulting in the fire space, and workshops and proof of concepts. We also are the team behind one of the largest smart on fire clinical applications in the country. We've been working quite heavily in that space as well. I'd like to share with you some technology that we've built largely as a result of sort of the voices of our customers. And what we found is that we can often think about what we hear from our customers in a couple different dimensions. And we have a couple different fire server products I'll talk about today. The first is a Java version, a product built in Java that was very focused on. It was built on the Cassandra open source NoSQL database. It's a very successful product for us, and what I'm also going to share is sort of our future direction too, and with some examples that I'm going to walk you through. Our customers, that you can think of how they, their reactions to some of our technology in terms of being either very database specific or often database less. And the Cassandra is a wonderful database. However, we often found ourselves in a situation where a customer would say, Steve, we have every database except for Cassandra. It's a very specialized, high performant database for very, very large data sets. At the same time, they would say, hey, we have petabytes of fire data on this S3 and we really like S3. It's a very inexpensive way to store lots and lots of data. The other dimension where we received a lot of feedback is on this dimension here, where we're comparing a commercial license, closed source, and full featured product versus an open community, open source, and more of an ingredient technology. And more we're finding our clients are wanting us to be in the upper end of this chart, where they're saying things like, we want a simple set of standalone tools to connect our customized data pipeline and workflow. So that's where we're headed, largely based on customer reaction and a lot of our implementation experience. We're largely headed in this direction, sort of up and to the right on this chart. And we've built a new version of our product, the Helios FHIR server, and it is an open source implementation of the FHIR standard, built in Rust for high performance and optimized for clinical analytic workloads. And what you're going to see here, there's several modules to it, and they are rather simple binaries that can be run as simple command line tools or a HTTP server that you can run as a microservice or Python bindings that you can embed directly in your data analytics pipeline. So what I'd like to show you next is some of the product. Actually, I'm going to walk you through some GitHub repos, but before I do that, I wanted to sort of frame all of the demonstration in terms of actually a very concrete use case that we've run into in a lot of our work. And this is a scenario where this is what's called the tests pending at discharge problem inside of hospitals. And hospitals have this challenge where they have often over 9,000 tests per month pending at discharge as an actual customer. And many of these tests could have been canceled prior to discharge, before they get out of the hospital, or not ordered at all. And many of them are also critical to post-discharge care and often at risk of falling into a black hole. And so you're seeing that these are days since discharge out of the hospital. And what you see here is sort of a barbell sort of pattern to some of the data, where some of these tests, these lab tests, are sent out to an external lab, or they're done in-house, or they're cultured. And even though the patient might be gone from the hospital, some of these tests are still pending and pending for many days, right? And this becomes a problem for hospitals, both financially and also from a care perspective. This is a case study of a 366-bed hospital, and just some of the costs relative to some of these tests. If you estimate them, if you sent them out, they might be $50 for a send-out test, $5 for an in-house test, or $10 for a culture test. These are average numbers. Some of these are reducible, like the in-house ones are probably 90% reducible. They maybe should have not have been ordered or otherwise canceled when it was known that the patient was going to be discharged. Just multiplying these, you can see these costs do add up, quite substantially for a hospital. The hospitals will not get paid often for some of these tests, but some of them they do want, right? So you have to be very careful about which tests might be canceled. In particular, the cultures are often an indication of a forecasted readmission risk. Those have to be grown. You can't largely cancel those, and that can be a readmission penalty that the hospital also incurs. So these are real world challenges with the hospital that they're running into. It's been studied in this paper and a Journal of General Internal Medicine back in 2018, and also, these are very interesting signals for a hospital of what might be happening just procedurally. 41 to 100% of discharges have at least one test pending at discharge, and 45% of patients with TPADs are readmitted in this study. So this is quite a challenge for organizations. So I'd like to walk you through that exact analytic question. This test pending at discharge question, using some of the software we have. All of what you're going to see here is open source and publicly available to you, available for download and for your use. The first repo here in GitHub is the Helios FHIR server itself, and this is built entirely in Rust. Rust, by the way, is a wonderful language. We've been building products in this language for some time. It is a very memory-safe language. It's a compiled language. In my early days in my career working in C and C++, you often wonder, hey, why can't the compiler just solve some of these memory issues that we have? And that's largely the question that Rust has answered. So it's a very memory-safe technology. There's been some studies from very large companies, including Google. Google, in one study, there was 1,000x reduction in memory-safe vulnerabilities in some of their code base as a result of using Rust. It's a very vibrant technology community, and it's a really wonderful, very very developer-friendly language to use. I've found. It's also very, very nicely aligned with healthcare challenges, healthcare design problems. Mostly it aligns with the FDA cybersecurity guidance. There's been some recommendations from the White House over the last couple of years in terms of language, increasingly use more memory safe technologies to ultimately reduce some of the vulnerabilities that might exist in healthcare and healthcare applications. So here is the Helios FHIR server. In the world of Rust, there are crates. A crate is a sort of a module in Rust, and we have many such different modules. What I'm mostly focusing on today are these two modules. Our SQL on FHIR implementation. I'll walk you through that. That includes a command line interface tool and also a HTTP server. Additionally, I'm going to show you there's a tool for Python. Many Python modules are actually built in Rust on the back end, believe it or not. Lars, a very popular data tool, is actually built in Rust, even though you're using it in Python. So I'll be showing you those. As Arjun mentioned in his opening, SQL on FHIR also includes, depends on FHIR path as a language. So there actually is a FHIR path implementation in the code base as well. All right, so I'm going to just walk you through the next repo very briefly, and this is also publicly available. I put this together for this conference, and so you can actually download this, clone this if you'd like, and run these yourselves. And what I'm going to do next is I'm going to stop this sharing, and I'm going to go over to a terminal and just walk you through some of these tools. And if I can find this one. All right. So mostly what I'm going to be doing is just copying and pasting from that second repo I mentioned, the Analytics on FHIR repo. So the first thing I'd like to share is, just what's in this directory. We have a soft CLI that's a command line tool for running the view definitions. There's also a soft server as well. I have generated some data using Cynthia that is modeled exactly after this test pending at discharge example. And there's a custom module that I built in TPD. Yeah, so this is a Cynthia module that really sets up this data quite nicely. Okay. If you're not familiar with Cynthia, Cynthia is a wonderful tool it's a realistic but not real healthcare data all on FHIR. Okay. And what we'll do next here is have a look at some of these view definitions very briefly. The first one, if you let's see, yeah. The first one is a view definition on an observation, and really what we're looking for here is all of we're extracting the observation ID, the code, the status of this observation, the effective time, and also the encounter ID. We're largely, if you imagine what we're about to do, we're largely going to be doing a join on observations and encounters, but we need to be able to get all that data. Okay. All right, and to do that, we're going to use the soft CLI command line tool, and this is quite straightforward. We're feeding it the view definition. We're feeding it, of course, the NDJSON data, and we're going to get a CSV output. The command line tools support CSV and Parquet and other formats as well. In this data set, there's about 10,000 patients with data. So what does this look like? So here we have observation IDs, or essentially flatten that data, flatten the input FHIR resource observation, and now we have this data to work with. Very, essentially rectangular format of that. We can do the same thing for encounters. So here we're doing running a view definition, the encounter view on a set of encounter data. And there's a little bit more data in here. We'll have a look at that. Encounters. Okay, so we have encounter ID, encounter class, type, start time, etc. All right, so we flattened essentially those two data sets. Next, I'd like to jump over to yet another way of doing this, right, which is running this off of a HTTP server. So in the background here, I'm running our soft server executable, and it conforms to the API specifications that Nikolai was talking to you about relative to actually running a view definition based on a server. And here is a very simple curl command for going against that view definition and feeding it again a set of NDJSON file of observations. And we are asking, and here is the lab observation view definition as a set of parameters. And here I'm actually returning the data in JSON format, again flattened. Okay. And then the third and final method here is a Python environment. And included in that repo is a very simple Python program that does really the same thing that we just saw, but it also is going to produce a nice data visualization. So here is PySoft importing a run view definition. We're loading up the data, both observation data and encounter data. We're running those view definitions, feeding in the view definition and the data. And then largely here, what we're doing is we're doing a merge and largely doing a join, a very simple join in this case on that data, making sure that we're getting the issued times correctly. Okay. So let me run that, and this also down below does produce a data visualization, which I'll show you as well. Running the transformation itself. Right, and I'm just going to open this test pending by day HTML. And for you to see that, I think I need to share this window again. And here you have it, a very similar chart that's modeled exactly that, that test pending at discharge solution. Before I open it up to any questions, let me share this last slide here. And I will share this presentation, but all of this material is out on GitHub, both the Helios FHIR server, and we are actively continuing development of the Helios FHIR server. Where we're going next is adding data layer to the Helios FHIR server, authentication layer, lots of other capabilities, really largely led in the direction that our customers are asking. All the material here, that example, that test pending at discharge and analytic example is available on GitHub. And for anybody on the call here, we'd love to invite you to an analytics mastermind group. We run this group a couple times a year. We'll probably be running it begin picking it up in January. As it's free, it's largely a group of people who are curious and interested about these kinds of problems that we've been talking about. We've helped organizations and individual people just learn some of this technology and work on interesting problems together. You can find me on LinkedIn. Please connect with me on LinkedIn. And I'm also lingering around chat.fire.org quite a bit, learning a lot and helping out wherever I can. And Arjun, I don't know if there's any questions.
Well, please, anyone post your questions in the chat for Steve. But I've got a few questions for you. Maybe we can go for a few more minutes before we get to Dan. But yeah, great work. I really love the fact that your work is really grounded in really important high value use cases. I was thinking as you're showing this test pending and discharge problem, and I was thinking every inpatient hospital probably in the world that does labs is going to have this issue. And here, particularly in the United States, we have readmission penalties. And so, I mean, you're talking about, in the average hospital at risk could be millions of dollars per year. So I wanted to ask you, just based on your experience and talking with the industry, yeah, what other kinds of use cases? I know you will work a lot of different kinds of industries, but what other kinds of use cases are you looking at for using this type of technology?
Yeah, we're finding a lot of work in the lab space, a lot of challenges relative to using this kind of capability in largely lab utilization. How do you apply this to labs? The other big challenge that is often found in labs and pathology generally is they're often treated as sort of an independent to the side component of the hospital, and they often have not had access to to the full set of data that might be found in an EMR, and whereas and increasingly they would like to be more collaborative with providers directly and with the ordering physician. And instead of just running the lab, often the question is, are we running really the right lab here? And how do you interpret the results of these labs in a much better way? There's also a lot of compliance items that were requirements that are largely unmet that we're finding, where again using data from the EMR largely in FHIR format, NDG, JSON format from an export. Those kinds
Mhm.
of analytic questions are now able to be asked and answered through some of these tools. And what we've done is we've made these, at least this initial set of command, largely command line tools, as low cost and as low, with the fewest set of hurdles to overcome, mostly internally. It's often a challenge to install a whole new data system, data architecture. So we're trying to find ways by providing these tools in open source in a very safe environment, and a great, really great technology being Rust, the language being
Mhm.
Rust, to make that available as easy as possible.
Yeah, that's terrific. I got that feeling as well that you've really been focused on this kind of, I call it almost Unix style tools, like really small focused tools that are very easy to chain together. And, it's a very practical and accessible approach. So, folks on the call who, you know, everyone has challenges with budget and contracts and, doing this big type of project. But I think you're showing a path where with these small focused open source tools, you can put them together in really powerful ways. Is that kind of how you
Exactly.
thought about the approach?
Exactly. That's precisely right.
Excellent. Okay, so there are no additional questions for Steve. I think